Okay, hello everyone. This tutorial video is showing how to solve a projectile motion problem. Here I have a question. A soccer player shoots a ball from 5 meters high above the ground, with the initial velocity is 15 meters per second. The ball was launched 60 degrees above the ground and traveled into the air until it dropped back to the ground. The player estimates that the ball will travel 30 meters away from the origin and reach the maximum height is 20 meters above the ground. Is the player correct? If not, what is the accurate result? So this is type of projectile motion problem. So we will annotate what is given in this question. I have diagram to show how the question is given. So there is a ball was shoot from a 5 meter above the ground in 60 degrees. So it will shoot the ball over here with 15 meters per second initial velocity, and it will drop back to the ground at this point. So the question asking the how far the ball has traveled through the movement and what is the highest distance the ball can reach, and the time taken for the ball to reach this position. Okay, so there are three formula that you can use to solve this problem. First one, S equal ut plus half gt square, v equal u plus at, v square equal u square plus 2as. So the u here represent for the initial velocity for both component, the vertical component and the horizontal component. The s is the displacement of the object travel. G and A is the acceleration due to gravity. T is the time taken for the object to travel. Okay, so first step, for the information given, I can determine that the velocity after the ball was launched and reached the highest point here. At this point, when the ball is going to the highest position, it will start to going down. So at this moment, the velocity of the ball will be 0. And we have v equal 0 and the u equal 15 meters per second. We can apply a equation for this. I use v equal u plus at. So the u here I am using is the uy, because I'm looking at the vertical component. So the uy will equal to u times sine theta, as I write here. So I have v equal 0 here, and the uy here, the acceleration due to gravity will be equal to 9.8, but because we are looking for the displacement, so we need to find the direction of the object at this position as well. So I'm looking for the vertical component, so the gravity will be going down. The gravity will be going down like this. So then this value need to be minus 9.8, because the ball was going upwards. the ball going upwards and the gravity going down. So the gravity will be negative 9.8. And I substitute negative 9.8 into here. Then I have 13 after I calculate ux or uy, sorry. So after I calculate, I got 13 over here. The initial velocity is 15, so 15 times sine 60, then I got 13. Then I have one hidden value is time, so that I can find the time taken for the ball to reach the highest point here. So I got t equal 1.33 seconds. So this is, so the ball, it means the ball takes 1.33 seconds to reach the highest point here. Okay. Next thing we need to do is we can use the formula sy equal uy times t plus half gt square to find the distance, the ground, to find the displacement of height that the ball reach the highest point. So here the uy will be equal to 13 because we are still using the vertical component, so we don't use cos theta here. And the t was 1.33, and again the acceleration due to gravity is negative 4.9, and this one t square. And after all, I found it 8.62 meters. But be careful, because this one is the displacement when the ball was launched. So that means here this one is 8.62 meters. And if we want to find the whole thing here, we have to add the rest of the displacement. Because the ball was launched 5 meters above the ground, so we plus 5 here. We get the final answer is 13.62. That means the ball reached the highest point at 13.62 meters. Okay, so next thing we have to find is the time taken for the ball to finish their movement. So again, I use the formula sy equal uy times t plus half g times t square. But this time is a bit different because I am looking at the displacement of the ball at the end. That means it's hit back to the ground. But as we see, so if we split this diagram, the ball was launched at 5 meters above the ground and it goes back to here. So that means the displacement was changed. And what I put in here is negative 5 because the direction is opposite the origin, 5 meters. So again, I substitute all the value that I have got in here, and this answer cannot give me an easy way to solve it, so I use the quadratic function to solve this problem. After substitute all the value in, I got t equals negative 0.3, but this one time can be a negative value, so I can't use it. And the other one gave me 3 seconds, so I will use this one. So we know that at this point the time second for the ball to travel was 3 seconds from the origin. Okay, now we have t equals 3 and v, this means ux equal u time cos 60 equal 7.5 meter per second. These two values, then we can substitute back to this formula to find the final distance here, but we are using the horizontal component. But however, the acceleration for the horizontal component, the g here, will be considered as 0, because the horizontal component, there is no acceleration for the horizontal component, and the acceleration for the vertical component is 9.8 due to the gravity, but for the horizontal it's 0. So that means we can cancel this part, because 0 times t will be 0. So we will keep this part to calculate the whole distance that the ball travel. Okay, so this is what I have got. SS equal ux times t, and the time taken to it travel back to it drop back to the ground was found as t equals 3 seconds. So I just substitute this value in. Ux was 7.5 times 3 seconds, so I have 22.5 meters. That means the ball hit back to the ground at this point is 22.5 meters. That's it. And now go back to the assumption of the player. Like the result was found as the maximum height the ball reached, which is 13.62 meters. So that means the player was wrong, because he estimated the ball can reach 30 or 20 meters above the ground. The time taken for the ball to reach the high point is 1.33 seconds, as we found in the first step. The total time taken for the ball was 3 seconds. Total distance the ball traveled is 22.5 meters away from the origin. So that means the player estimated wrong. He estimated 30 meters away from the origin. And the displacement of the ball from the origin is negative 5 meters, because it was hit from the ground. This 5 meters, but the ball go back to here. So that means negative 5 meters for the displacement. So therefore the estimation of the player was wrong. Thank you for listening.